right, for this last problem now, another application of lines. So we're going to do a little bit more digging into an applied scenario. So the graph shows the amount of gallons Y in a 100-gallon tank after X minutes have elapsed. So we can kind of see we have a line that's going downhill. On the one side we've got water in gallons, and then across the bottom we have the time in minutes. So the first question is water entering or leaving the tank. How much water is in the tank after 3 minutes? So what would you say based off of the graph? Is water entering or leaving the tank? So we can kind of see that the time is increasing as we go from left to right. And then what's the water level as time increases? So we can see it starts at 100 and it's gradually going down as time goes on. So we can safely say that it is leaving the tank. So all right, and now how much water is in the tank after 3 minutes? So, well, we can use our graph and kind of say, okay, we have 0, we have 3, so 3 is this line here. Let's go our way up here, and it looks like it's going to be about 70, and we want to make sure we include the units. So after 3 minutes there's 70 gallons in the tank. Now I'm being very verbose here, but it doesn't hurt to write things out in a sentence. You could have said 70 gallons and that's answering the question, but it's nice to make sure you understand the context of the question as well. Find both the X and Y-intercepts, interpret their meanings. All right, well, so the X-intercept and the Y-intercept. So what would you say for the X-intercept for this line? Remember, intercepts are where it crosses the respective axes. So it's crossing the x-axis right here. So that ordered pair would be 10, 0. So what would the y-intercept be? Yeah, so it's going to be crossing up here. So again, for using ordered pairs, let's make sure we're careful. So now we want to interpret what they mean though. So what does this x-intercept of 10 mean? Well, what do we know about the water level when 10 minutes have passed? It's right at 0 now. The water level is at 0, so there's no more water in the tank. So this is the time when tank is empty. Something along those lines would be fine. So the tank should be out of water. And 0, 100. Well, so that's the tank at full capacity. That's when the tank's starting at time 0. The tank is starting with 100 gallons of water. So tank initially contains 100 gallons of water. So that's kind of how we can interpret it within the context of this question. All right, let's keep going. 2 more parts. Find the slope-intercept form of the equation of the line, interpret the slope. All right, so what do we need for our slope-intercept form? What 2 things? We need the y-intercept, which we got, but we also need the slope. So what's the slope? Well, it's going over 1 and down 1, over 1 and down 1. So it's going over 1 down 1, is it -1? No, no, you got that right. Because the scales are different. Remember, the scale over here is each square is 10 units, not 1 unit. So it's going down 10 for every 1 unit over. So this needs to change subtly. And so -10 would be our slope. So now we have the slope and the y-intercept. So we should be able to quickly say y equals -10x plus 100. So there's that. But now, how do we interpret the slope? What do they mean by that? So let's try to think about what we got here. So it says -10 over 1. So think of that in terms of the units. So remember, the units vertically are gallons of water, and the units horizontally is time in minutes. So this is a -10 gallons over 1 minute. So -10 gallons over 1 minute. So it's actually losing water at a rate of 10 gallons per minute. Every minute, 10 gallons is lost. After another minute, another 10 gallons is lost. So so a slope of -10 means that for each minute, I'm going too fast, each minute that passes, 10 gallons of water is lost. So that's the rate at which that water is leaving the tank. 10 gallons per minute. All right, last question. Estimate the x-coordinate of the point x50 that lies on the line. All right, so they're telling us we don't know x, we need to know y. We have a y of 50. So if we start with a y of 50, which would be right here, work our way across, stop, and come down. Looks like 5. So x is equal to 5. And let's put the units in there. So 5 minutes. All right. So, these types of problems are where, it really is, you see those applications and how it can be useful in, the everyday world. The math world, it's different, but in the everyday world, it's nice to know how things apply. So hopefully that helps clarify some things for you. All right, new section, next video. So we'll see you very soon.